We made it to the 90s. Welcome to Algebra 1 CST release question number 90. It says Lisa will make punch, that is 25% fruit juice, by adding pure fruit juice to a 2-liter mixture, that is 10% pure fruit juice. How many liters of pure fruit juice does she need to add? So this one, not super clear, I don't think, as to what the answer is going to be or where we're going with this. But if you watched number 87, that is good. Or number 86, I'm sorry. That's going to be very similar to this one here. So we're going to use this idea, this saline problem that we had. Excuse me, that we had for number 86. Use that same idea to help us solve this one. So instead of 10, 15, and 12, we're using over here 25, 10%, and then the pure fruit juice is 100%. And so how much do we need of each one? So let's make a little table like we had there in 86. I don't know why that was so crooked there, but hey, life happens. It's just how it'll have to be, I guess. We'll be fine. So the final mixture I want is 25%. I mean to put that down here. And then we're adding 100% the pure fruit juice. So pure, we're thinking 100%. We're taking a certain amount of that, 100%, adding it to a certain amount of the 10% to get this 25% mixture. So how much of the 100% are we adding to the 10%? Do we know how much of that? No, that's what we're trying to figure out. So I'm going to call this X for right now. So this is the amount of pure fruit juice that we have, or the amount, or the liters in the mixture itself. So this is going to be the amount of pure juice, and this is the liters in the mixture. So for the 10% part, we know we're making this 2-liter mixture that is 10% pure fruit juice. We're adding this pure fruit juice to a 2-liter mixture to get that. So what we have right here, just 2 liters. And so 2 liters, 10% of that is pure fruit juice. What's 10% of 2? That would be 0.2 right here. And so from there we have the amount of pure juice in the 100% mixture, in the pure mixture. It's still going to be the same thing. It's still going to be X, because 100% times anything is that same thing that you started with. And then 25%, how much are we going to have in that mixture? We're going to have whatever we have for the pure juice plus the 2 liters with the 10% mixture. So we're going to have X plus 2. And then the amount of pure juice in each mixture, in the 25% mixture, should be X plus that 0.2. And so from here, we can also think of the amount of pure juice as this times this, just as the 10% times the 2 is 0.2, the 100% times the X is X, the 25% times the X plus 2 could also be the amount of pure juice that we have. So we could think of it as 0.25, which is the same as 25%, times that X plus 2. So notice I can say the amount of pure juice is either this plus this, which is right here, or I can say it's 25% of the X plus 2, which is right here. And so I can take these two things right here, this X plus 0.2 and the 0.25 times the quantity X plus 2, and I can set them equal to each other. They have to be equal to each other, since they're just alternate ways of saying the amount of pure juice. So I have X plus 0.2 has to equal 0.25 times X plus 2. Now, a couple different ways we could tackle this problem. We could either leave them in terms of decimals and work it out like that, or we could get rid of the decimals by multiplying everything by, I want to get both decimals to move 2 spots to get rid of all the decimals. So in order for this to move 2 spots here, I'd have to do the same thing here. I have to do the same thing to both sides of the equation, remember. So I'm going to multiply everything by 100 on both sides of the equation. So times 100 here, times 100 here. Let's see what happens. The 100 I'm going to have to distribute to this. But since this is this times this, the 100 I would just multiply it by this one. By multiplying it there, it's also getting distributed through to there. And so let's see what I got left after I do that. I've got 100 x plus, this moves the decimal 2 spots here, multiplying 100 times 0.2, that's going to be 100x plus 20 equals 25 times x plus 2. Now I can distribute that 25, and I'd have 100x plus 20 equals 25x plus 50. From there, subtract 25x from both sides, and subtract 20 from both sides. 25x's will cancel, the 20's will cancel. You'll have 75x equals 30 right here. I'm going to continue that idea up here. Take 75x to get x by itself, which is the amount of pure juice that we're adding to this mixture in the first place. That's what we want to solve for. It will be our final answer. If I divide by 75, I've got x equals 30 over 75. Now that can be reduced. Looks like I can divide both of those things by 15, actually, is the biggest number that I'm seeing right now. Could divide by 3, I could divide by 5, but since I can divide by both 3 and 5, might as well do it all at once and divide by 15. That leaves me with 2 over 5. Now 2 over 5, that equals, as a decimal, 1/5 is 0.2, so 2/5 would be 0.4. So that means you have to add 0.4 liters to this mixture, this 10% mixture, to get a 25% mixture of pure fruit juice. If you're adding 8 liters of 100% to 2 liters of 10%, yeah, I think that one was probably a little bit of a stretch to think that you're going to add 8 liters of a pure fruit juice mixture to 10%. A 10% mixture that's only 2 liters, you'd have way higher than 25% fruit juice in that concentration or in that mix. So 8 liters, yeah, you could have eliminated that one right away, but between these other 3, I don't think it's quite as clear. 2 liters probably can eliminate as well, because you've got 2 liters of the 10%, and to have 2 liters of the 100%, that's a half and half mixture. That's going to be a little over. That should be 55%. It's halfway in between there. So that really doesn't make sense either. But your right answer, based on our actual working it out here, if we didn't have these answer choices, we still want to be able to work it out. Choice A looks like the right choice for number 90.